Hey everybody, welcome to part 2 of our linear modeling discussion here. And I got another example, and I did get this from Delta Math, so that's full disclosure here. And let's read this. And I think what they want us to do in these problems is take the context from the equation itself. Given that we know b, y-intercept are initial amounts, and that rates of change are your slope. And they always have a context when we're doing these problems. So Sebastian filled up his car with gas before embarking on a road trip across the country. The number of gallons of gas remaining in his gas tank after t hours of driving can be determined using this equation. G equals 10 minus 1.25 t. What is the x-intercept? Well, I think that I might want to say, in this case, it would be a t-intercept, but that's what they mean. And what is its interpretation in the context of the problem? We're going to answer that question, but I want to answer some others on the way. All right, and the first thing I want to talk about here is what does this function do? Right, and like I said, if you can't answer that question, you don't have good control of your function. So let's write it down here on the notepad and just take a second just to sketch out the big idea and what this thing does. So we've got G is equal to 10 minus 1.25 t. Okay, now our ordered pairs input is time in hours, right? Because this is and G is the number of gallons remaining in the tank. So what we're looking at here, time goes in hours, right? An hour goes in, or number of hours, and gallons come out. Okay? That's the first thing you got to wrap your head around. Now, what does it mean to where we're looking for an x-intercept? But before we jump on an x-intercept, let's talk about that y-intercept. And we know what it is. Now, they got this thing written a little bit backwards. It really could be written as negative 1.25 t plus 10. So you might have more easily recognized that y-intercept in that form. It's got a negative slope. Well, it makes sense that it should, doesn't it? Because the car isn't gaining gas as it drives down the highway. It's losing fuel, right? And it looks like the y-intercept is 10. So what does that mean? At time 0, there was 10 gallons. Okay, so it's a full tank. Right, and as time increases, this is going to take away from that 10. So that 10 is going to be going down. Now, all right, so let's just note here, y-intercepts are always 0, b, right? And x-intercepts are always, in our case here, we're going to have a time and a 0 for g. That's what an x-intercept is. All right, so what we need is to put that 0 in for g and solve the equation to answer the question. Then we can discuss the context, okay? So we need to solve. 0 equals negative 1.25 t plus 10. All right, now that's not a whole lot of work. We'll subtract 10 from both sides to start with here. Minus 10, minus 10. And just don't break any rules here, and we'll get this thing out of the way. And finally, we'll divide by that negative 1.25. And of course, you could use a calculator. And I find that t is 8 when I do that division. Okay, so we got an x-intercept of 8. And we'll write it like this. So in 8 hours, there are 0 gallons of gas. So what does it mean in context? That the car can drive an average of 8 hours on a tank of gas. That's what that thing means in context. Let's see if we missed anything. We kind of took that thing completely apart. All right, we said, hey, this 10 right here represents the number or the number of gallons when we don't have any hours on the tank at all. We have not driven. It's a full tank. We said it made sense that it had negative slope because the fuel is depleting. The number of gallons is always going down. You're not gaining fuel or riding down the highway. Okay? And we said define the y-intercept you plug in 0 for x, define the x-intercept you plug in 0 for y. They always work that way, folks, every time. And we can answer that question. I think we have. And let's make sure we did. What is the interpretation in the context of the problem? I think we answered that very well. And let's see if we have time for this next one in this video. Yeah, we'll try to fit example 3 into, and I'm going to show you a quick way to do example 3 on another video, because there's 2 ways to do this one. All right, it says Savannah is going to use a computer at an internet cafe. The cafe charges an initial fee to use the computer, then an additional price per minute of usage. All right, let C represent the cost of using a computer for T minutes. So they're telling me right now what my variables are and what they mean in context. So C is a cost for using that computer for T minutes. So a minute goes in time and a cost comes out. The table below has selected values showing the linear relationship between T and C. Determine how much money Savannah would have to pay if she used a computer for 4.5 minutes. Okay, so there's right many issues with this. And let's clear our board here, and we can kind of just start filling in some of these details. So it sounds like what we want is a cost function, don't know the rate, and I don't even know the y-intercept, right? I don't know any of that stuff right this minute, because I'm looking at that table, and I don't see a 0 for t. So I don't have a y-intercept, folks. I don't even have a rate of change or a slope. Now that's not hard to find, is it? Since this is a linear relationship and it says it right here, we can locate, we can not locate, but we can compute a slope really, really quick here. So let's do that. I'll clear my calculator out. And what I'm going to do is I'm going to subtract 13.2 minus 11.6. And, well, we'll just do it this way. 11.6 minus 8, and then 7 minus 2.5. Let's go ahead and calculate that. So we'll go in here and get us a template. Make sure we're careful with our fractions. And we want 11.6 minus 8. Right now, I'm computing a slope, right? 7 minus 2.5. And I get so that's our rate. So it looks like they're charging 80 cents per minute. Wow. That's what it sounds like, right? With an initial fee that we don't know yet. So what we just found now is that M is equal to 0.8. All right. Now the next part of this is writing an equation of a line, like you've done for so many times. But you've got to pick one of these ordered pairs and just go with it and write your equation of your line. Substitute this in for y, this for x, and use the slope you just found. So I'm going to pick that first ordered pair because the numbers are a little bit smaller. And let's just calculate it like this. So we're going to pick 2.5 and 8. And I'm going to write y, which is c, equals m x plus b. Okay? And when we get ready to do this calculation, it's perfectly okay for you to use your calculator. So I'm going to say 0.8 times my 2.5, right? And that gets me 2. Okay. So now we have 8 equals 2 plus b. After 8 equals 2 plus b. And finally, I'll subtract 2 from both sides and get the b is 6. All right, now finally we can fill in our function and answer their question. I don't know about that color. Let's go with green. So our function, our final job here is c equals 0.8 t plus 6. And this is built to make predictions. Remember, this is going to give me a cost for any time that I want. And the question was, how much does it cost for 4.5 minutes? And we'll come in here and we'll just go to our calculator and answer that. We're going to plug in 4.5 for t. So we'll clear that out and say our slope, 0.8, times 4.5, that's the number of minutes, plus that initial fee, which we found out was $6. And we'll hit enter, we get $9.60. So it costs $9.60. That sounds pretty expensive to me, but you know, I'm an old guy. So it looks like when we plug this stuff in, like we just did, C equals 0.8 times 4.5 plus 6. That's an ugly 6. So your cost is $9.60. All right, I know that was a long video. We did a lot of work with those two functions, and this one right here, I'm going to show you another video of a way to make light work out of this one. It can be done much easier than that, but if it was calculator inactive, well, I used a calculator, but I didn't use it in a big way. But I'll show you another way to do this with our TI-84 that I think you're going to like. So I'll see you in the next video. It'll be a short one.